Assalamualaikum everyone. Welcome back to our channel, The Atomic Mind. I hope you all are doing good. In last lecture, we have discussed some basics of motion. Today, I come up with another topic, and the topic is Newton's first law. This law is also called law of inertia. Let's move to our topic. Have you ever wondered why a rolling football eventually stops, or why our body jerks forward when a car suddenly halts? These everyday situations are not random. They are explained by Newton's first law of motion. Newton's first law of motion says an object at rest stays at rest and an object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced force. Now, what is an unbalanced force? Unbalanced force is when forces acted on an object are not equal, resulting in net force that is not zero. To understand this, let's discuss if the forces are balanced, the net force is zero and the object motions remain unchanged. The net force is zero because all the forces will cancel each other and the resultant net force will be zero. Now discuss what is inertia. This law introduces another new term, inertia. Inertia is the natural tendency of the objects to resist change in their state of motion. We can say that it is the property of matter to stay at rest or in motion at a constant speed and direction unless acted upon by an unbalanced force. Let's understand it in more easy way. A heavy truck takes longer to stop than a bicycle because it has more inertia. Your phone stays on the table until someone moves it. It resists motion because of inertia. The amount of inertia depends on the mass of an object. The greater the mass, the more inertia it has. Means it has more resistance to change its state of motion or rest. Let's discuss some real life examples of inertia. Number one example is that when your car suddenly stops, your body moves forward. Why? Because your body was in motion and it wants to stay in motion. That's inertia. That's why seat belts are essential. They provide the unbalanced force needed to stop your motion safely. Example number two of inertia is that you may have seen magicians pull a tablecloth from under dishes without moving them. That's inertia. The plates resist sudden motion and tends to stay still. Another example of inertia is that a ball lying still will never move unless you kick it. It's at rest and want to stay at rest. However, when you apply an unbalanced force, it will start moving. Now, a question may arise in your mind, why do things eventually stop? A ball slows down and stops on its own. Does not that it contradict Newton's law? Actually, no. The ball stops because of friction, an external force. If we remove all friction, like in space, motion would continue forever. Have a look on friction. Friction is a force that does not allow motion or opposes motions when two surfaces are in contact with each other or two surfaces are sliding or tends to slide over each other. It acts in the opposite direction of motion. The amount of friction depends on the roughness of two surfaces. The more the surface is rough, the more irregularities it has, so it produces more friction. Friction allows us to walk on the road without slipping, and it's make difficult to slide a heavy brick across the floor. Wrapping up our topic, discuss some points. Newton's first law explains that motion or rest continues until something changes it. That something is called an unbalanced force. The resistance to change is inertia, which depends on the mass. Real life examples are everywhere from car seat belts to football and space travel. This law lays down the foundation for understanding how force interacts with objects and how our everyday experience are shaped by physics. In the next lecture, we will explore Newton's second law, where we will connect force, mass, and acceleration. Thank you for watching, and if you found this lesson helpful, don't forget to like, share, and subscribe for more physics made simple. Ending with the question, can you think of a real life example where we have experienced Newton's first law in action? Share it in the comments. Thank you. Take care. Goodbye.